Relays. Today we are going to learn about relays in details. If you like this video, please give it a like and subscribe for more electrical video updates. We use relays for a wide range of applications such as home automation, cars and bikes, automobiles, industrial applications, DIY projects, test and measurement equipment, and many more places. But what is a relay? How does a relay work? What are the applications of these relays? Let us explore more about relays in this video. What is a relay? Okay. A relay is an electromagnetic switch operated by a relatively small electric current that can turn on, or off a much larger electric current. The heart of a relay is an electromagnet, a coil of wire that becomes a temporary magnet when electricity flows through it. You can think of a relay as a kind of electric lever. Switch it on with a tiny current and it switches on, leverages, another appliance using a much bigger current. Why is that useful? As the name suggests, many sensors are incredibly sensitive pieces of electronic equipment and produce only small electric currents. But often we need them to drive bigger pieces of apparatus that use bigger currents. Relays bridge the gap, making it possible for small currents to activate larger ones. That means relays can work either as switches, turning things on and off, or as amplifiers, converting small currents into larger ones. Relays can be of different types like electromechanical, solid-state. Electromechanical relays are frequently used. Let us see the internal parts of this relay before knowing about it working. Although many different types of relays are present, their working is same. Every electromechanical relay consists of an 1. Electromagnet. 2. Mechanically movable contact. 3. Switching points and 4. Spring. Electromagnet is constructed by wounding a copper coil on a metal core. The two ends of the coil are connected to two pins of the relay as shown. These two are used as DC supply pins. Generally, two more contacts will be present, called as switching points to connect high ampere load. Another contact called common contact is present in order to connect the switching points. These contacts are named as normally open, NO, normally closed, NC, and common, COM, contacts. We can use a relay either in an AC circuit or a DC circuit. In case of AC relays, for every current zero position, the relay coil gets demagnetized and hence there would be a chance of continuous breaking of the circuit. So, AC relays are constructed with special mechanisms such that continuous magnetism is provided in order to avoid above problem. Such mechanisms include electronic circuit arrangement or shaded coil mechanism. How a relay works. Relay works on the principle of electromagnetic induction. When the electromagnet is applied with some current, it induces a magnetic field around it. A switch is used to apply DC current to the load. In the relay, copper coil and the iron core acts as electromagnet. When the coil is applied with DC current, it starts attracting the contact as shown. This is called energizing of relay. When the supply is removed, it retrieves back to the original position. This is called de-energizing of relay. There are also such relays, whose contacts are initially closed and opened when there is supply. Solid-state relays will have sensing element to sense the input voltage and switches the output using optocoupling. Relay contact types. As we have seen that relay is a switch. The terminology, poles and throws, is also applicable for relay. Depending on the number of contacts and number of circuits it switches, relays can be classified. Before we know about this classification of contacts, we have to know the poles and throws of a relay switch. Poles and throws. Relays can switch one or more circuits. Each switch in relay is referred as pole. Number of circuits a relay connects is indicated by throws. Depending on the poles and throws, relays are classified into 1. Single pole single throw. 2. Single pole double throw. 3. Double pole single throw. 4. Double pole double throw. Single pole single throw. A single-pole single-throw relay can control one circuit and can be connected to one output. It is used for the applications which require only on or off state. Single-pole double-throw. A single-pole double-throw relay connects one input circuit to one of the two outputs. This relay is also called as changeover relay. Though the SPDT has two output positions, it may consist of more than two throws, depends on the configuration and requirement of the application. Double-pole single-throw. A double-pole single-throw relay has two poles and single-throw, and it can be used to connect two terminals of a single circuit at a time. For example, this relay is used for connecting both phase and neutral terminals to the load at a time. Double-pole double-throw. A DPDT, double-pole double-throw, relay has two poles and two throws for each pole. In motor direction control, these are used for phase or polarity reversal. The switching action between contacts for all these relays is performed when the coil gets energized. Types of relays. There are different types of relays like electromagnetic relays, latching relays, electronic relays, non-latching relays, reed relays, high-voltage relays, small signal relays, time delay relays, multi-dimensional relays, thermal relays, differential relays, distance relays, automotive relays, frequency relays, polarized relays, rotary relays, sequence relays, moving coil relays, Buchholz relays, safety relays, supervision relays, ground fault relays. Relay applications. Relays are used to protect the electrical system and to minimize the damage to the equipment connected in the system due to overcurrents, voltages. The relay is used for the purpose of protection of the equipment connected with it. These are used to control the high-voltage circuit with low-voltage signal in applications audio amplifiers and some types of modems. These are used to control a high-current circuit by a low-current signal in the applications like starter solenoid in automobile. These can detect and isolate the faults that occurred in power transmission and distribution system. Typical application areas of the relays include lighting control systems, telecommunication, industrial process controllers, traffic control, motor drives control, protection systems of electrical power system, computer interfaces, automotive, home appliances.